Decades in the making and launched mere months ago, the Plankton Aerosol Cloud and Ocean Ecosystem, or PACE, is giving us a first glimpse at promising new data from the sea and sky.
It's a mission that's exciting because PACE makes the invisible visible. It's flying hundreds of miles above Earth, and yet it's designed to see microscopic things.
PACE is seeing the ocean like no other mission has before. While previous ocean color satellites could only detect a handful of wavelengths, PACE is detecting more than 200 wavelengths. And more wavelengths mean more pigments.
Tiny organisms called phytoplankton contain green pigments that allow them to photosynthesize, which is really important if you care about breathing and eating. But their pigments make them many, many shades of green, and that contains a ton of information.
The more information revealed by PACE's hyperspectral ocean color instrument, the more details that emerge from our changing ocean and coastal communities, like how one group of phytoplankton can dominate a particular area.
You can see kind of that in chlorophyll. I mean, you see that in chlorophyll, that pigment. But once it starts popping up from this view, the PACE allows us with all these different phytoplankton. Once again, you see so many different miniature, teeny tiny features that are maybe not that important physically, but they're important enough to make one type of phytoplankton win, one type of phytoplankton be dominant versus the other.
And you care about this because not every community is the same. Some are beneficial. They provide food and oxygen. Others close beaches. So we really want to know where they are and when they appear and the impact of all of this.
PACE is also giving us an early look into aerosols, microscopic atmospheric particles like dust, sea salt, pollen, and volcanic ash. The two polarimeter instruments on board measure the light bouncing off the particles at many different angles.
This scene represents observations at a number of different geometries as the spacecraft flies over. So it's about 5 minutes of time elapses between the first observation at one angle and the last observation looking in the backwards direction.
Moving through the different angles reveals the sun glint reflecting off the ocean's surface. Analyzing the geometry of that sun glint gives us more details about that environment.
If you want to observe the ocean itself, inside the ocean body, you can't do it when you see the sun glint reflecting off like that. So having lots of different viewing angles allows you to see geometries where you can see what's happening in the body of the ocean as well.
That's only the surface. We really understand where the color comes from, what is really inside in the atmosphere, and what is inside the water, right? There's a deep meaning of those stuff. And so in order to really understand them, we need more information.
And I cannot wait to be on the far end of launch with data flowing and data quality looking great, just absorbing what the community comes out with, because I think we're all going to be really surprised and really, really pleased.